We are continuing to look at ellipses in this study of analytical geometry. In the first video, we spent some time understanding here are the two equations for ellipses, understanding the center is HK and what A and B are. And we looked at if we were given equations of ellipses, we could extract all the information and then graph the ellipse. But now there's two other kinds of problems that we're going to have. And here's the first one where sometimes they give you the graph of an ellipse and they want to know the equation of this ellipse. So that's the first problem we're going to do here now. So let's first make sure we understand whenever you're given a graph, you've got to really be careful about making sure you're reading things correctly. So for instance, if you look here, here's 0, and you can see up here is 2. So this is like the y-axis, and you can see the x-axis is 2 and 2. So it looks like, it doesn't show it here, but this would be, this is of 1 and the positive y. This would be 1 and the positive x and negative 1 here. So here is your origin. So there is 0, 0. First thing we want to do, even before maybe we start looking at this graph and try to figure some things out, let's just go ahead and determine which equation we should use for this ellipse, right? For ellipses, two equations. This equation, since x is always, since A is always larger than B, this is the equation that we would use for a left to right ellipse. And this is the equation for an up or down. Pretty obvious here that this is going to be a left or right ellipse. So I should just go ahead and write down the equation for a left or right ellipse. So let me write it down here below. So from my little sheet, the left or right ellipse is x minus h squared over a squared plus y minus k squared over b squared equals 1. So that's the standard equation for what we call a left to right ellipse. Now we know in the equation, the final equation will have x and y as your variables. So therefore the things we need to determine are the h and the k and the a and the b. And of course, h and k are an ordered pair. That's the center of the ellipse. And then A is going to be the distance from the center to the major vertice. And then B will be the distance from the center to the minor vertice. So we look at this graph. Let's go look at this graph and figure out what the center is. And then we should be able to also, from this graph, determine A and B. So the three things we need to determine are the center, this distance A, and this distance B. We should be able to look at this graph and figure those three things out. So you just have to be very careful with this. So for instance, if I want to find the center, if I look here, the left edge of this ellipse, I'm actually going to write this point down here. So this point is going to be 0, 2, and the right edge of the ellipse, this point, this is one of your major vertices, is 6, 2. That should be pretty clear. If we want to find the center, we need to find the midpoint of this. So if it goes from 0 to 6, this distance is 6, so halfway is going to be 3. So even just the eyeball test shows that this is going to be the center. And if we go up and down, you can see here, this point here is 3, 1. And this minor vertex here is 3, 3. So you can really eyeball this. I put in these coordinates here, which you don't really need, but just to make it very clear. The center is going to be half of this distance. From here to here is 6, so half of it's going to be 3. And then half of this distance from here to here is 2. So half of it's going to be 1. So we can see the center is going to be 3, 2. Now this distance here is going to be A, which is going to be from here to here, 1, 2, 3. And from here to here is B, which is going to be 1. So basically, we've got all we need. The center is 3, 2. A equals 3. B equals 1. So we plug in 3 for H over here, 2 for K over here, plug in 3 for A and 1 for B, and then we should have the equation. So X minus H, X minus 3, quantity squared over A squared. A is 3, 3 squared is 9, plus Y minus K. K is right here, 2. So Y minus 2, quantity squared, over B squared. B is 1, so there's really no fraction here. And then this equals 1. And just to confirm that, here at the bottom of this graph, it actually types out the equation of the graph. X minus 3 squared over 9 plus Y minus 2 squared equals 1. So honestly, in my opinion, for this analytical geometry, ellipses are pretty straightforward. Once again, we determined it was a left and right ellipse. So here's standard equation. Then your job is just to find 3 things: the center, and A and B. And from looking at the graph, we can quickly find those 3 things, and you plug them in and you're good to go. So once again, with all these analytical geometry types, it's like the 3-legged stool, right? You've got the equation, you've got the graph, and you've got information. So this is an example where you start with the graph, and they ask you to determine the equation. Now there's one type of problem left, and that's where they give you information. And in this case, they want you to come up with the equation. So here's information you're given. You're told you have an ellipse, and they give you the vertices. And of course, by vertices, they mean the major vertices. So it's 1, -1, and -5, -1. And then they say, here's what they say in the homework, so I'll use the same phrasing. They say this ellipse says passing through or passes through another point, -2, 1. When they say passing through this point, they're basically saying this is a point on your ellipse. Just like if I go back to the previous problem, you know, this point here, 6, 2, is a point on the ellipse. You just look at the ellipse and you choose a point and it's on the ellipse. So they give us 1 point on the ellipse. And then what they want to know is, what's the equation of this ellipse? In my opinion, to do this kind of problem, what you really need to do is to sort of create a graph and mark these points, and you can really see what's going on. If you try and do it in your head, you're just asking for trouble. So let's make a quick sketch with this information we're given, and we then can see if we know what's going on. So this will be a quick sketch. So let's go 2, 3, 4, 5. So the major vertices, or the vertices, are 1, -1. So let's be careful to graph this. So 1 in the x direction, -1. So there's one vertex. Go ahead and put a little v there. Then the second vertex is -5, -1. So it's -1, 2, 3, 4, 5, -1. So there's another vertex. So when I graph, it's very obvious that this is going to be a left or right ellipse. I can't draw it yet because I don't really know how far it's going to go up and down. But if these are the major vertices, I know it's a left or right ellipse. And just for fun, let's go ahead and plot this point here, -2, 1. So basically we know the ellipse is going to go through this point. Oops, I graphed it wrong. Sorry. It's going to go through this point. So if we know it's a left or right ellipse, let's go grab the standard equation for a left or right ellipse. Once again, this is where this comes in handy, and this is the equation for the left or right ellipse. X minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. So just like the last problem, anytime you're trying to determine the equation for the ellipse, you need to know 3 things. You need to know the center, because the center will give you h and k. Then you need to know a, you need to know b. Well, what do we know? Well, I can determine the center because I have these 2 vertices. The center is going to be right in the middle, halfway between these 2. So it looks like this is 1, 2, 3, 4, 5. So this is of 6. So halfway between is going to be 3. So 1, 2, 3. So here is going to be the center of the ellipse. And it looks like this point is going to be -2, -1. So right now, I know my h and k. H is -2, k is -1. Matter of fact, I can go ahead and start writing my equation. So x minus a -2, which ends up being x plus 2 quantity squared, let's hold off on the A for a minute. Y minus K, K is minus 1, so Y minus a minus 1 is Y plus 1. Once again, let's hold off on writing the B squared for now. Now, can we determine A and B? As soon as we can figure out A and B, then we'll have the equation. Well, A is the distance from the center to your major vertices. So we can see from the center to the vertices, distance of 3. So it looks like A is 3. So 3 squared is 9. So now the last thing we have to determine is what is B squared. Now from the information we're given in our little sketch here, we can't really determine B squared for sure. It might be this point, but we don't know. So what we're going to do is, for now, since we can't determine B automatically, we're going to leave it in here. But we need to now mathematically see if we can figure out a way to calculate B. And this is where you use this point on the ellipse. In other words, they're telling us -2, 1 is on the ellipse. That's like saying you can take a point whenever x is -2, y is going to be 1. I can take this point, and since it is a point on the ellipse, I can plug that point into this equation. Because when I do that, then you'll see the only variable I have left is going to be B, and therefore I can solve for B. So what this means is I'm going to take this point on the ellipse, and plug it into my equation I've come up with so far. So -2, plug in for x, and 1, plug in for y. So I'm going to do that. So I'm going to say plug in the point -2, 1. So you have -2 plus 2 squared over 9 plus y plus 1. Y is 1. 1 plus 1 squared over b squared equals 1. So you can see, it looks a little messy because you have fractions here, but you can see there's an equation with only one variable. So we can actually solve this for b. At this point now, the goal is solve this for b. And once we do that, then we can plug it back into our ellipse equation and we should be done. So let's solve this for b. So up here, -2 plus 2 is 0. Well, that's actually sort of nice. So 0 squared, 0 over 9 is 0. This whole first fraction is just 0. 1 plus 1 is 2. 2 squared is 4. 4 over b squared equals 1. And this is a pretty straightforward algebra equation to solve. If I multiply both sides by b squared to get it out of the denominator, I'd have b squared equals 4. And what do I have to do to go from b squared to b? I need to take the square root of both sides. And you get b equals, remember, you take the square root of a number, you have to have plus and minus. So b is plus and minus 2. Doesn't really matter plus or minus. All I really care about is the number for b. So basically, we can say b is 2. So I plug in 2 for b here, and then my final equation for this parabola, this ellipse. So b is 2, so this is 4. So this is the equation for the ellipse given this information. As a matter of fact, I went ahead just to confirm it. I graphed this. So let's look at the graph and see if this information is true. So right here, I look at the bottom of my graph. Look at the bottom of my graph. This is the graph of x plus 2 squared over 9 plus y plus 1 squared over 4. So this is my equation I've come up with. So here is the graph. Now the question is, this information I've been given, does it make sense for this graph? Let me do this real quick so maybe we can try and see it. Here's information we're given. The vertices should be 1, -1 with this graph. Here's the origin. So 1, -1, 1, -1. So this is -1 here. This is 1 here. So 1, -1 is right here. We're saying that's a vertex, which looks correct. And then -5, -1. -5 is here, and -1. We're saying that's the other vertex. And then we're saying the ellipse goes through the point -2, 1, which is right here. So yes, it looks like this is correct. All right. So those are the two other kinds. So there's 3 kinds of problems you're going to be given with ellipses. First of all, they'll give you the equation and they'll ask you to figure out the information and then graph the ellipse. Secondly, they will just give you the graph of any ellipse, and usually they end up wanting the equation of the ellipse. Now, when you find the equation of ellipse, you normally figure out the information. You have to figure out the center, the A and the B. So that's the second kind of problem. The third kind of problem is where they just give you information about the ellipse, and they want you to come up with the equation. And that's what we just did. All right, so that's what we have going on with ellipses.